What is a beam column? In structural engineering, a beam column is a structural member that is designed to resist both bending due to an applied load and axial forces due to compression or tension. It is a common type of structural member used in building construction and other engineering applications. A beam column consists of two main components: a beam, which is a horizontal or sloping member designed to resist bending, and a column, which is a vertical member designed to resist axial forces. The two components are connected at their ends to form a single member that is capable of resisting both bending and axial forces. Beam columns are commonly used in building construction as part of the framing system. They can also be used in bridges, industrial structures, and other applications where both bending and axial forces must be resisted. The design of a beam column involves careful consideration of the loads to which it will be subjected, as well as the materials and geometry of the member itself. It is essentially a combination of a beam and a column, where the member is designed to resist both vertical loads acting on the column and horizontal loads acting on the beam. In a beam column, the beam portion of the member is typically responsible for resisting bending and shear forces, while the column portion is responsible for resisting axial forces, such as compressive or tensile forces. The transition between the beam and column is often gradual, with the section gradually increasing in size towards the base of the member to accommodate the increasing axial forces. Beam columns are commonly used in buildings and other structures where there are both vertical and lateral loads that need to be supported. They are particularly useful in seismic areas where there is a high likelihood of earthquakes, as they can provide greater resistance to lateral loads and help prevent the collapse of the structure during an earthquake. The design of a beam column involves consideration of both the bending moment and axial load that it will experience under service loads and ultimate loads. The cross-sectional size of the beam column is determined based on the maximum stresses that will be induced in the material under these loads. The design of a beam column is crucial to ensure that the structure is safe and can withstand the loads that it is designed to carry. The beam column is an important component in the overall stability of a structure, and its failure can have severe consequences. Therefore, it is essential to ensure that the beam column is designed and constructed to meet the required safety standards. The design of beam columns involves taking into account the loads that act on them, the properties of the materials used to construct them, and other factors such as safety considerations and environmental factors. The design of beam columns is critical to ensure the safety and reliability of the structure they support. I hope you've learned a lot from me. Goodbye for now.